Taking from what we observed in the previous slide regarding the distribution of the sample means, we introduced the central limit theorem, which is one of the most important theorems in statistics. Simply put, the central limit theorem states that if all samples of a particular size are selected from any population, normally distributed or not, the distribution of the sample means is approximately normal, and this approximation improves with larger samples. This is a very important concept in statistics because it allows us to use the standard normal distribution for computing probabilities, even for non-normally distributed populations when the sample size is large. The figure on the following slide demonstrates this concept. So from the chart on this slide, we see 4 original population distributions on the top row, none of which is normal. Observe the change in the shape of the sampling distributions, that is the distribution of the sample means, converging to a normal distribution when the sample size is increased from 2 on the second row to 6 on the third row and to 30 on the fourth row. This is the essence of the central limit theorem. Most statisticians consider a sample of 30 or more to be large enough for the central limit theorem to be employed. We use another example on this slide to develop an explanation of the essence of the central limit theorem. Spencer Sprockets employs 40 people and faces some major decisions regarding health care for these employees. Before making a final decision on what health care plan to purchase, Ed decides to form a committee of 5 representative employees. The committee will be asked to study the healthcare issue carefully and make a recommendation as to what plan best fits the employee's needs. Ed feels the views of newer employees towards healthcare may differ from those of more experienced employees. The lengths of service of the 40 employees currently on the Spence Sprockets payroll are listed on this slide. Given this data, we ask and answer the following questions. If Ed randomly selects this committee, what can he expect in terms of the mean years with Spence Sprockets for those on the committee? How does the shape of the distribution of years of experience of all employees, the population, compare with the shape of the sampling distribution of the mean? The chart on the top level shows the distribution of the years of experience for the population of 40 current employees. Note that the distribution of length of service is positively skewed since there are a few employees who have worked at Spence Sprockets for a longer period of time. The chart on the lower left row is a histogram of the average length of service for 25 samples of 5 employees, or a sample size of 5. The chart in the lower right row is a histogram of the mean length of service for 25 samples of 20 employees. What we can consider from this example is the essence of the central limit theorem, which indicates that, regardless of the shape of the population distribution, the sampling distribution of the sample mean will converge towards the normal probability distribution.